Hello, I'm Andre and welcome to a new episode. Some people look for the pattern of the prime numbers, but I think it would be more useful to look to the pattern of all the numbers, looking at the number of their divisors. So, for example, all the prime numbers have only two divisors and all the other numbers have more, with the exception of one which has only one divisor. So we know that every prime number except for 2 and 3 are on of the form 6k plus 1 or 6k minus 1, which means that they are above or below a multiple of 6. Take for example 5. 5 is 6 minus 1. 7 is 6 plus 1. 11 is 6 times 2 minus 1, and 13 is 16 times 2 plus 1. And that's true for all the prime numbers except for 2 and 3 because they are smaller. And some people look for a formula that when we plug in a prime number and the formula gives us the next prime number every time. And let's say we start with 5 because 2 and 3 are some prime numbers that don't follow all the rules that the other primes do, like we saw earlier with 6k plus 1 and 6k minus 1. And let's say we know them and we just need a formula for the rest, or even if we start with 2. And that formula, if we plug in 5, we get 7. If we plug in 7, we get 11, which is the next prime number. And that formula isn't known because people search for it, but we didn't find it yet. So, but there must be a pattern because these are prime numbers and they have this rule to have only two divisors. And the prime numbers have only two divisors, which are 1 and itself. But 1 has only one divisor, which is 1. Itself is still 1, so it's not. It's the same thing, so it's not a prime number. So actually, a good way to visualize the prime numbers is to make a grid of numbers, a list like this, and in this table, the length of the row must be 6 or some multiple of 6, like 12 or 18. And I'll show you in a few moments why. So if we do this, we can see lots of patterns. So actually this is a very good method to calculate the prime numbers. So I wrote down here a table of prime numbers up to, well, they are not only prime numbers, these are all the natural prime numbers except for 0, up to 102. And if you make such table, well, we know that 1 is not prime because I told you earlier why. And then we know that 2 and 3 are primes. And then if we know that all the prime numbers are a multiple above or below, 1 above or below a multiple of 6. And we know that on this table all the multiple of 6 are on this row. So all the prime numbers bigger than 2 and 3, so all the prime numbers that we can find from now are only on this column and on this, so on the first and on the fifth column. They can't be anywhere else. But that doesn't mean that all the prime numbers are here and they're only primes. They are also composite numbers like 55, and I'll show you how to exclude them. So first, let's exclude the obvious ones. Here, in the second column, we have all the multiples of 2, and we just exclude them like that. Here are only multiples of 3, so they can't be prime. We exclude them too. And on the fourth row, there are also only multiples of 2, so we exclude them because they can't be prime. Here on the last row, I told you that are only multiples of 6, so they can't be prime. And now let's see, we must consider the multiples of prime numbers. So the next prime number is 5. Okay, and what are the multiples of 5? well, 10, which is here, and then 15, 20, 25. So we can see that they are placed diagonally like this. So you have we excluded them like this with a diagonal line, and we also excluded 25, which is on a column with prime numbers. And the next multiple of 5 is 30, so actually we go straight here and make another diagonal line to exclude the multiples of 5, and we do that for the entire tower of numbers. And if we want the prime numbers up to 100, we also need to consider the multiple of the next prime number, which is 7. And what are the multiples? They are 14, 21, 28, 35, 42. So we can see that they also go diagonally like this, so we exclude them with this line. Okay, we see that all the numbers that we excluded were already excluded. And the next prime number, no, sorry, the next multiple of 7 is 49. So actually we don't go straight like this, we go straight and go down 2 boxes. So straight go down 2 boxes and make the line. So actually now we excluded the number, and go on like that, and another number that we excluded, and now we go straight here 2 boxes below, and like that. And actually this is all we need for all the numbers up to 100, and this is true for 102 too. But if we want more numbers, like here where we have 360,000 numbers, we need to take care of multiples of more prime numbers like 11, 13, 17. But if we take, let's say for example 13, which is a prime number, a multiple of 13, let's say 13 times 7, is right here, 91. But we can see that we already excluded that by a multiple of 7. So actually for what we made now, that's all we need. So all the numbers we are left with are primes. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, and we also have 101 here is a prime number. So this is true, these are the prime numbers. So at first the prime numbers look pretty random, but here we can see what the rules are. So here are more ordered in an order. We have only these lines, so now it's much simpler. It's still pretty hard, or we don't know a easier way to predict where the multiples of 5, 7 or other prime numbers will take place in these vertical lines, but it's already something. And this is the reason why we have here these vertical lines. And actually I made another version of this photo, of this image. So the more red the color is, the number has less divisors. And if we have these bluish colors, or closer to violet, the numbers have more divisors. And we can see that around these blue lines there are some red spaces, because these blue lines are numbers with lots of divisors, and these are the multiples of 24. So these are all multiples of 24, and this of 30. So 24, okay. And this means that 24 is also a multiple of 6. So the prime numbers must be around this line, because 24 is a multiple of 6, and the prime numbers are 1 above or below a multiple of 6. So this is why we have these red nuances here, these red hues. So this is very interesting. So this is the pattern, and I'm sure if we analyze this pattern better, we can see the formula for the primes. And I also made, I don't know if you can see it on this version, but there are also some very thin diagonal lines that are yellow. But to see them better, I made another version of this. So it's actually the same thing, but instead of colors we have now black and white. So the more white the number is, the more divisors it has. So we can still see that vertical lines, but we can see now the diagonal lines much better. And I think this is because of these multiples of the prime numbers. And actually, if it's a really big multiple of a prime number, it has many divisors. So I think that's the reason why here are these diagonal lines. It's also this one, which is more interrupted. It's not so continuous, but we can see that. I think that's a multiple of a bigger prime number, like 13 or 11 or some big prime number. And we have these big numbers that are also multiples of 24. This, I think it's a multiple of 24. Let's check that. So these are highly composite numbers, and they have lots of divisors, and they are also multiples of 24. So that means that they are on these blue lines with lots of divisors, with numbers with lots of divisors, and that's the reason why they are these blue lines. And we can see if we go further, we can see like an orange square, because the majority of the numbers up to 360,000 have like 10 divisors in average, because that orange shade is correspondent to 10 divisors. And this is a very interesting fact. I think the number is bigger if we go if we check more numbers, because it's or maybe I really need to check that. And I tried to make this on the paper first, so I made this, but I only managed to do it up to 45. Of course I can do it much further, but I realized that I made some mistakes, because these are the colors, and I think I made some mistakes on this. And these are the orange number are the prime numbers, because they have only 2 divisors. But this is a very slow process, and I don't need to do that, because it's too much work and a few results, and it would take, I don't know how much, but very long time to calculate up this many numbers. Imagine that it took me like 10 minutes to calculate only 45 numbers, but it took this computer just 5 minutes, so half the time to calculate 360,000 numbers. So actually, how I made this image, how did I make it? So I made a program in JavaScript. I used some HTML too, but it's mostly JavaScript, to calculate the number of the divisors of the numbers, and to attribute them a color in function of the number of the divisors, using HSL colors. So we are using the hue, and the bigger the hue is, the more divisors the number have. So if the hue is 0, we have like a color wheel. Let me show that. So we have like a color wheel, and if we have 0 degrees, we are in the part that's up in the circle, which is red. Then if we rotate like 90 degrees, we have something like this shade. If we have a turn of 120 degrees, we have green. 240 degrees mean this cyan, and 360 is where we started, so it's also red. So on this color wheel we have all the colors of the rainbow and also some magenta after the violet to turn back to red. And in function of the hue we have the colors and also the the number of the divisors of the number. So I made that program to make my process a lot faster and to have a lot more numbers. So this is how the program works. We can see that we have a line here that travels, and it actually counts all the numbers, and the length of this is 600 numbers, and we already can see these vertical lines that are yellow here, and it goes on like this. So I think this is a very interesting property of the prime numbers, and not only for the prime numbers, it's the pattern for all the numbers in general, and I think that's very interesting. So that's what I wanted to show you in this video. I will make more videos on this subject, so don't forget to subscribe to not to miss these videos, and I will see you in my next video. Bye.